Hey viewers, and you are welcome to Mlt channels. This is Engineer Oladipo, your host and your amiable online tutor. Today's subject is chemistry and the topic of discussion is stoichiometry. You are welcome on board. Without wasting time, let's quickly dive into details. And today's learning goal is problem solving in stoichiometry reaction. All right, we have some questions to try. Question of the day. So we have a reaction in which 1 mole of nitrogen reacts with 3 moles of hydrogen to produce 2 moles of ammonia. All right, let's check this question from classroom. All right, so we have the question now. Consider the balanced chemical equation for the synthesis of ammonia, Na3, from its elements. And we have the equation of the reaction. 1 mole of nitrogen reacted with 3 moles of hydrogen to produce 2 moles of ammonia. So use the coefficient to answer the following questions. Option A, that's question A. Determine the molar mass of ammonia. So we want to know the molar mass of ammonia. All right, let's return to MLT virtual classroom to do that. All right, so we are attempting question A first. All right, that's awesome. So let's identify the problem. Determine the molar mass of ammonia. Okay, so we are looking for molar mass of ammonia in this question. So the next thing is to get the molar mass of ammonia. And molar mass is represented by capital letter M of Na3 is equal to unknown. Okay, let's enlarge that a little bit more. All right, that's perfect. Then that is the task at hand on question A. Then how do we get molar mass? To get molar mass, we are going to need the relative atomic mass of the element involved. Okay, let's get that. The relative atomic mass of nitrogen is actually 14. You don't need to stress yourself on relative atomic mass. If needed, you'll be given. But let's, as in this kind of question that we're not given, just multiply the atomic number by 2 for even numbers. Then for the odd number, you may add +1. So the atomic number of nitrogen is 7 plus, so then 7 multiplied by 2, that is 14. So the atomic number of nitrogen is 14. Then that of hydrogen, its atomic number is just 1. Is 1. So we have the atomic numbers now. So we can now easily get a molar mass. So that implies that the molar mass of ammonia now, Na3, will be equal to ammonia, the nitrogen relative atomic mass is 14. So we have just 1 atom of nitrogen present in ammonia multiplied by 1. Then plus relative atomic mass of hydrogen is 1. Then multiply by, we have 3 atoms of hydrogen present in ammonia. Then this should give us 14 multiplied by 1, that gives us 14, plus 3 multiplied by 1, that gives us 3. Then 14 plus 3, that's equals to 17. Then the unit of molar mass is gram per mole. Okay, so that's the answer to the first question, which is question A. Let's record that in the space provided for the answer. So we have 17 gram per mole. Okay, the unit has already been stated here. Now let's check that and confirm that in the class. So 17 gram per mole. Let's submit that. Oh, that's perfect. That's correct. All right. So let's try the B, which is the second question. How many moles of ammonia can be produced by the reaction of 14 moles of nitrogen gas? Okay. Again, let's go back to MLT virtual classroom. So now we are attempting question B. So let's identify the problem. What's the problem in question B? How many moles of ammonia So we are looking at the number of moles of ammonia that can be produced by a reaction of 14 moles of nitrogen. Okay, that's good. So let's start that. We are looking for number of moles represented by small letter n. Okay, number of moles, number of moles of NH3 is unknown. Okay, S supposed to be here. Let's enlarge that a little bit more. Okay, that's good. So let's bring that to question B. So how do we now get the number of moles of ammonia? In order to get that, we need the reacting moles. And according to the equation, the reacting mole, we have, okay, let me use the red pen. We have 1 mole of nitrogen gas liberate or produce 2 moles of ammonia gas. So we have to use the reacting mole first, okay? So in doing that, we say 1 mole of nitrogen gas liberate 2 moles of ammonia gas. Okay, let's enlarge that a little bit more. Okay, that's awesome. Let's bring that here. So here is the reacting mole now. 1 mole, according to the equation of the reaction, 1 mole of nitrogen give 2 moles of ammonia. Now, the required now is the mole that the question wants us to get. So we want to know the number of moles when the mole of nitrogen is 14 moles. So now say 14 moles of nitrogen now liberate 'X mole of ammonia. Okay, that's good. So the next thing we need to do here is actually to cross multiply. And to cross multiply that, we have 1 mole of ammonia, 1 mole of nitrogen multiplied by X mole of ammonia, then 2 moles, and then 14 moles of nitrogen multiplied by 2 moles of ammonia. Okay, so let's put that down. So we have X multiplied by X multiplied by, okay, let's just say X mole now, so that I'll be able to differentiate. X mole of ammonia multiplied by 1 mole multiplied by 1 mole of nitrogen equal to 2 moles of ammonia multiplied by 14 moles of nitrogen. Okay, so let's enlarge that a little bit more. Okay, that's okay. So let's bring that here. So we have x mole. So then we have cross multiply that. We have cross multiply x mole of ammonia by 1 mole of nitrogen and equals to 2 moles of ammonia by 14 moles of nitrogen. Okay, that's good. Then that implies that 1 mole multiplied by x mole, that will still give us x. That means x mole of ammonia will now be equal to 2 multiplied by 14, that's 2 moles, multiplied by 14 moles divided by 1 mole. Okay, so mole will cancel mole. So what are we now left with? We are now left with x equal to, that is 2 multiplied by 14. That is actually 28 moles. Okay, there's a slight mistake. Instead of me writing 14, I wrote 12. 14 moles of ammonia. That implies that when 14 moles of nitrogen reacted, is going to liberate 28 moles of ammonia gas. Okay, let's correct this. It's supposed to be 14. Okay, that's correct. So now let's put down our answer for question B. So our answer is 28 moles. Okay, let's confirm that in the software. So we have 28 moles. Let's submit that. Oh, that's perfect. That's correct. All right. We have 3 more questions to go, which is question C. How many grams of ammonia can be produced by the reaction of 14 moles of nitrogen gas? Okay, let's return to the virtual classroom. So this should be the last question. So learners, you are going to take question D and E as your assessment. So let's identify what we are looking for. We are looking for number of grams of ammonia that can be produced from the same 14 moles of nitrogen. Okay, number of grams, that implies that we are looking for mass now, which is represented as small m, mass of ammonia gas produced. That is equals to unknown. Let's explain that a little bit more. That's great. So then we know that the formula we are going to adopt here is mole, which is represented by small letter n, equal to reacting mass small letter m over molar mass capital letter M. Then the mole of ammonia gas that reacted is what we have just gotten in question B. So it's 20. When we were given 14 moles of nitrogen gas, then 28 moles of ammonia gas was produced. So that implies that our number of mole, which is N for ammonia, equal to 28. And that is equals to the reacting mass is unknown. That's what we are looking for. Then the molar mass of ammonia, we have gotten that in question A, which is equal to 17. So if we make mass the subject of the formula now, that implies that mass will be equal to 17 multiplied by 28. So if you punch your calculator very well, let me quickly punch my calculator to check that. 17 multiplied by 28. That gave me 476. So that's supposed to be 476 grams. Okay, let's put that in this space provided for the answer. 476 grams. That is the mass of ammonia produced. Okay, let's check that in the classroom. 476. Let's confirm that. Let's submit our answer. That's also correct. That's awesome. So learners, you are going to take question D and question E as your assessment. So question D, how many moles of ammonia can be produced by the reaction of 51 moles of hydrogen? So if you follow the steps that we've done earlier, you should be able to get that correctly. And the last but not the least, how many grams of ammonia can be produced by the reaction of 51 moles of hydrogen? So almost the same methodology with B and C. All right, learners, it's been so fun, so engaging, and so exciting. I hope you have gained or learned one or two things in today's class. If so, don't hesitate to join us in the next video. All right, learners, 16 minutes just gone now, like 16 seconds. So you can register for our physical and our online classes. And our office is at Omega Building, opposite Gasland Nigeria Limited, Obafemi Awolowo Way, Malete, Ibadan. And you can contact me directly. Here are my WhatsApp numbers: 08067076871, as well as 09155684169. You can watch more videos on our YouTube channel, and our handle is youtube.com/@Oladipo2262. We also have our videos on TikTok, and our handle is tiktok.com/@Mlt Tutors. Join us or connect with us on Facebook, and handle on Facebook is facebook.com/mlt.tutors. At MLT Online Class, we are rooted in sound values, driven by academic excellence, building the future through qualitative learning and digital literacy. Until I come your way again, I remain my humble self, Engineer Oladipo, your host and your amiable online tutor. Assist us by liking and sharing this video. Subscribe to our YouTube channel as well. Bye for now, and thank you very much for watching.